All right, today's lesson is 10.7. It's called Graphing Linear Inequalities. This is my third attempt at doing this today, and I keep having technical difficulties, so hopefully this one works. So, graphing linear inequalities. If you're confident graphing lines using slope-intercept form, I think you'll find this lesson to be quite simple. If you're not that good at graphing lines using slope-intercept form yet, this lesson will help you get better at that. Let's start with an example. So number one, if we had 3x plus y is less than or equal to 3. If this was an equation, such as 3x plus y equals 3, we would solve this for y and put it in slope-intercept form. And that is exactly what we're going to do, even though it's an inequality. So we're going to subtract 3x from both sides. Remember, we want that 3x term, or that x term, to be first, because that's where the slope is. So I'll just underline that. That's the slope. And this is the y-intercept. And we just start graphing. So the y-intercept is at 3. So I'm going to put a dot at 3 on the y-axis. The slope is negative 3. And remember, a slope of negative 3 means negative 3 over 1, but it could also mean 3 over negative 1. The top number in that fraction is the rise. So a rise of negative 3 means you go down 3, and a run of 1 means you go to the right 1. So down 3 to the right 1, and I'm going to do that a couple times. Down 3, right 1, down 3, right 1. Using the right fraction, it could also mean up 3 and left 1. So 1, 2, 3, and left. So I'll make a dot here, and I can make another dot here. So far it's exactly the same as graphing a linear equation. So I'm going to connect these dots. Hopefully I'll make somewhat of a straight line here. Okay, good. Good. So there we go. So that is the graph of y equals negative 3x plus 3. How do we make it the graph of y is less than or equal to negative 3x plus 3? It's pretty simple. First of all, if y is less than, if we think about this line and we think about above the line, this is everything above the line, and this is everything below the line, because what we're talking about is the y value. The y is less than. So the negative 3x plus 3 is the line. The y, meaning the how high or how low it is, that's what we're talking about. So we want the y to be below the line, because it's less than. So we shade everything below the line. So everything is shaded. That means any coordinate in the shaded region will be an answer. I should have shaded that in blue, by the way, because the line is blue. And the line, in this case, is included in the shaded region because it can be less than or equal to. Okay, and we can prove that by picking any point on the line, for instance. If we choose this point 0, 3, I'll write it down, 0, 3. If we plug that into the inequality, it works. Negative 3 times 0 plus 3 is greater than or equal to 3. So that does work, and we could pick any point in the shaded region here. I'll pick, let's try something easy like negative 2, 0, right? So I'll write it out here because it would be lost in all the red and blue. So let's try negative 2, 0. It's in the shaded region. Let's plug it in. So negative 3 times negative 2 is 6, plus 3 is 9. So 0 is less than or equal to 9. That's true. So that's correct. Now let's pick a number outside of the shaded region, like 4, 0. Let's try that. We're going to assume that that is going to make the statement not true. So let's find out. Negative 3 times 4 is negative 12. Plus 3 is negative 9. And then our statement would be 0 is less than or equal to -9. This is not true. Not true. This one was true. Right, that's this 0, 3. And then this one was also true, right? So you can see anything in the shaded region should work. Anything not in the shaded region should not work. That's how you check your answer. So remember, y is the height. Okay? Y is always the height. So at any given value for x, like 3, for instance, down here. Oops. So at an x value of 3, we want the height, the y value, to be less than the line. So that's why we're shading things under this line. Okay. Let's try another example. The next example is y is less than 1. Y is less than 1. I'll call this example 2. It's already solved for y. We could, what is the slope? Well, the slope is the coefficient of the x term. If there is no x term, the coefficient must have been 0. And let's put that in a different color to show that that wasn't actually in the problem. But we have to assume that the slope was 0 here. And the y-intercept is 1. So we have a slope equals 0, and the y-intercept equals 1. So the y-intercept of 1 means we're going to start, let's move that up a little bit. We're going to start at 1. A slope of 0 means 0 over anything. We'll put 2. But it could mean 0 over -2 or 0 over 5 or something like that. So all we need to know is you go up 0 and you go over every amount. So we could go up 0 over 1 or up 0 over 2 and over, we could go left. So up 0 over -3. What we'd find is we have all these points on this line. Okay, so now we've graphed the equation y equals 1. So how do we make it y is less than 1? Well, y being the height, we want the height at every x value to be below the line. And so we are shading everything below the line here. Okay, everything on the graph below the line. Now, what about the line? Is the line itself part of the solution? Let's check. Well, it says y is less than 1. So if we check it, let's try the point 2, 1. Let's see. Is 1 less than 1? No, it's not. So that shouldn't work. Well, let's try this point here. -3, 1. Notice there's no x value, so we don't have to worry about that. So is 1 less than 1? No. So how do we show that the line itself is not part of the answer? So take a little eraser. Let's make it a real little one. We just make the line dotted. So now our line is dotted. And that shows that, hey, this is the boundary line. We need that line there, but it's not actually part of the answer. But everything lower than that line is part of the answer. Okay, and you can try by plugging in different points. Like if you plugged in this one here, 1, -1, you would find that -1 is less than 1, so that's cool. If you plugged in 4, 6 or something like that, it's outside of the shaded region, so we're assuming it's not correct. So we plug in 6 is less than 1, not true. So it's just that shaded region below the line. That is pretty much all you need to know from this chapter that's different than graphing equations. So the only difference between graphing, so let's write this out, difference between graphing an equation and an inequality. Alright, and its differences. There's a couple things. So the first thing is shading. Equations don't have shading, inequalities do. And the other thing is a solid or dotted line. Equation lines are always solid. Inequalities can be solid or dotted. Solid would be if it looks like this, or this actually, right? Dotted line would be when it's just this or that. And also, rarely we have that one as well. So dotted would not include any equals. Solid would include everything equals. Let's try one more. Oops, I'm already here. So let's try x is greater than or equal to -2. Notice we're not talking about y at all in this case. We also won't be able to use slope-intercept form because there is no slope. But what we do is find all the points where x equals -2. So like this one, and this one, and this one, and this one, and everything in between, and this one, and this one, and that one. So all that stuff. So we're basically making a vertical line where x is always -2. And also that is a no slope as opposed to a zero slope, because there is rise and there's a zero run, but you can't divide by 0. Here we need x is greater, and that's pretty obvious. X is greater on this side, right? Because x of 4 is obviously greater than an x of -2. This does have an equals in the inequality, so greater than or equal to. So we use a solid line. And that is it. We're done. So these can be pretty quick once you know slope-intercept form. For your homework, I would like you to do problem 1. Let me write these down. Problem 1 is y is greater than or equal to 4. And not problem 2. But the second problem you'll do is going to be y is greater than, I want a less than actually. Y is less than x plus 5. Oops, not an equal to. Erase that. Y is less than x plus 5, and that is number 9. So do those two problems. You're going to need graph paper for this homework. Thank you. I can't find that.